Shane, can you give me host permissions?
I think Saad, can you? I don't think I can because I'm only host can. I'm a co-host.
Yeah, let me
So I have
see.
already started recording.
Mm-hmm.
Okay. All right, Srini, you should be co-host.
Sid, you need to make me the host. My name is Sid.
Oh, sorry, Sid. My bad.
No problem.
Hang on, let me. Oh, I made Xing the host. Now let me reclaim host. Okay, there we go. Sid.
Great. Yeah.
Okay, there we go.
Okay. Sharing. Let me turn this off. Okay. All right. So I want to quickly give an update on the progress and development that we've made, and then talk about topology. So on Monday this week, we were talking about actually moving the project from our temporary repositories to Kubernetes official repositories. And also we were talking about the progress of end-to-end testing. So this is kind of the progress that we had at a big picture level. And let's look at what we have today. In terms of the actual components, we have more or less the features implemented that we wanted to for the initial demo. The thing that we're all focusing on right now is integrating the 4 components and making sure they all work together. So Srini here is working on end-to-end testing for the entire project. If I maybe Srini can give an update on this pretty quickly.
Yeah, I'm mostly working for the last week on the CI setup, testing from ProwJob and then the Prow, customizing the Prow.sh. As part of that Prow.sh, it's the same like the CSI, so it's gonna install Ginkgo and run Ginkgo with a focus. So ETE run part is in place. I have basic skeleton code. I still haven't implemented any tests yet. Not much in there.
Okay, Srini, thanks. So that's where we are. We're still on track as of now. The bottleneck right now is moving all the code into official repos. And that seems to be the step that's taking a little more time than anticipated. However, we're still moving very fast, and if we continue going at this pace, we should still be able to show the demo by before the holidays at the end of the year.
That's
so, sorry?
Yeah, I just wanted to say that, yeah, we do not want to move the code until we have some kind of validation checks and verify scripts in place. That's the reason. If not, there is no reason for us to hold on to it. It becomes easier to review code that way. That's the reason.
And also it becomes easier to onboard more people to start contributing. And we have at least a basic testing framework in place.
Yep.
We know that the code is more or less right. On that front, I think one of the things we wanted to talk about was, Srini, there was something we wanted to bring up about the spec repo. Is that correct?
Yeah. Right now, currently, I put out 2 PRs in there. One PR that triggered the discussion about the region and that you're going to cover in the next in the topology part. The other part is adding approvers for the spec repo, I am requesting only one approver. That would be Sid, and then I changed to have two of us as reviewers, so that as we go along, we may end up making some changes to the spec. So we need a good turnaround on the repo. So please look at that PR and see if that can be merged, so that we'll have a bit of control on updating the spec. Right now, I checked in the first draft of first spec .md, which is in line with the KEP. But as we go along, we talked about credentials, and so there might be a few minor changes to the structures here and there. So if we have a bit more people, more reviewers and more approvers, then our turnaround time will reduce a bit. Does it make sense?
If I understand correctly, so I haven't been closely following this, so I'm asking. I thought we were going to, as the people who are implementing this, we should be able to at least have someone who can approve and move this forward. Is that not the case?
I have approved like all the other branches. This is the spec branch, spec repo, right? So I was going to check with that because I thought the CSI spec repo has a very limited number of approvers. That's why I was like wondering, Sad, what do you think? Should we add more people to the spec repo as approvers, or should we keep what we have now so that we can have more people review it before it's merged? Because spec, I'm thinking that should not be changed that often. What do you think?
I think you're right, Shing. But I'll let Saad answer and we'll go.
I would agree with that sentiment.
So I think that's absolutely right. The one question I have though, should we start doing that after maybe alpha or beta? At this stage, it's kind of still in flux. And you know, I can see us adding and changing things. And again, it's not even alpha, so maybe it's not really solidified yet. And I'm sure after the API review, probably something's going to change.
But I think we will remove approvers after adding them. That's
true. It's harder to remove.
But at the same time, I did change the list though. I mean, I'm only adding one person as an approver and two as reviewers. That's like where I am right now. So
yeah, I think one of us should be there.
So I reviewed, I think last time I reviewed the PR, I was just having some comments because it's different from the merged cap, right? So if you have something that is exactly the same, I think that should have no problem of getting that merged. But if there are changes, I think we probably should get more people look at it still.
I see what you're saying. Yeah, of course. I mean, we can, you know, if it's just me on there, I'm sure I'll you know, I'm not going to push anything in without getting either you or Saad to take a look also.
Okay.
Yeah. Okay. We'll update the PR. Shini, please update the PR to just have.
I updated the PR, and Saad and Shing, please review that, and we'll take it from there. Whatever. Yeah.
Okay. If you could you shoot me an email? Serve as a reminder for me to take a look.
Okay, sounds good.
Sorry, thank you.
No problem.
All right. Okay. So topology. While looking at the PR, Shing brought up a really good question about last Thursday, I believe. We had two fields in our protocol field, in our protocol structure inside of a bucket, and they were region and zone. Now, region and zone apply to all the cloud providers. However, in bare metal deployments, region and zone do not directly translate. For instance, inside of a data center for a particular organization, They are less likely to have the concept of a region and zone. They're more likely to have the concept of racks. And people could come up with different ways of slicing and dicing topologies. And great conversation ensued from that discussion. And we more or less decided that we should implement topologies just like CSI does. And to that end, I've just put together something, and I want everyone's input on how we can take this forward from this. So in order to facilitate this, so this would be a change in create bucket gRPC protocol, where when we call create bucket, we would tell the provisioner that it needs to create a bucket that's accessible from this particular topology. This is similar to what CSI does, where in case of a volume request, there's a call called create volume to the CSI controller, where it provides a list of topology constraints that say that a volume should be accessible from something that satisfies this topology constraint. And it's the provisioner's job to provision a bucket that's accessible from some node or some set of nodes that satisfy the constraint, and then respond with whatever that set of nodes are as a topology segment. Now, I'll go into what the difference between a constraint and segment are, but for those of you familiar with CSI, it's exactly the same difference between a constraint and segment in the CSI spec. The topology constraint structure, again modeled after the CSI structure, is going to be a list of key value pairs. And there's going to be two fields, a required and preferred constraints. Required constraints and preferred constraints. So required constraints are those that need to be satisfied by the provisioner when provisioning the bucket, and preferred, which has to be a subset of required, is preferably satisfied as a best case effort. A segment, in contrast to this topology constraint, is just a single map string that satisfies or that denotes the topology in which the bucket is available. So this is more or less how I'm thinking about it. One last piece to this is how Cozy will know about which topology or which node belongs to which topology. So we want to rely on node get info from the CSI driver for now. So the node agent is a CSI driver, and when it starts up, Kubernetes calls a function called node get info, which responds with the set of topology fields or topology descriptions that apply for that particular node. So
do you mean to be saying CSI or Cozy?
CSI. So CSI. So we have a CSI driver internally.
Oh, okay.
Yeah.
That's CSI driver.
Mm-hmm.
Yeah.
We want to rely on that to get the node topology for now. Again, this is something I'm freshly thinking about.
But I mean, from the perspective of the spec, it should just be the CO's job to figure this out, right? And then we happen to know how we're going to do this in Kubernetes.
I mean, how will the CO figure it out?
Well, I mean, it's not our problem, right? In the CSI spec, this equivalent decision is just like said, well, the CO has to pass in some topologies, and that's the CO's, it's up to the CO to.
Yeah, but how will
so we could say that in our case, the RCO is going to use a CSI driver to do that, right? And this just becomes an implementation detail for Kubernetes.
fair? Yeah, that's what I meant.
Okay.
What is the exact information in those strings? Is it node names or?
No, so it would look like it looks like a label. So it would be, for instance, the keys are defined by the user or the admin who sets this up, and the values again by the admin who sets it up. So it would be something like say a list of things like region R1 and then zone Z1, and then drive type NVMe or something like that. And let's say that goes into the required. So it's a list of key value pairs. If you have multiple items in the list, like I said, if it is region R1 and then a next list item zone Z1 and the next list item drive type NVMe, then it's Boolean and operation between them. That is, all three should be satisfied. If it is within the same map, then it is, say, region R1, zone Z1, and drive type NVMe is within the same map, then either one of them should be satisfied, if I remember correctly.
Sounds a little counter. Maybe I'm missing the direction, but it seems like one map would represent an end kind of relationship between the different keys, right?
Sorry, can you repeat that?
I think it would best be just give an example here of the array because it's really hard to.
Yeah. Fair enough.
Maybe it's just me, but
no, I'm sure. Yeah. Yeah, here. Yeah. So they call it requisite. It's basically a list of map strings. So yeah, it looks like that. So
in JSON world, it's an array of objects.
Yeah.
And objects are string to string, and then the string keys are property names for the identifying the topology type, and the value is a value which, how do I mean, as a provisioner, how do I parse this information in my cluster, right? So that's what you said, right? I need to go and maybe get the related regions somehow, right?
Yeah, so for instance, in this case, take the simpler case, let's take just this one. So in this case, a volume or a bucket should be accessible from region R1 and zone Z2. I don't know if you can see it clearly.
That's good, yeah, no.
Yeah, region R1 and zone Z2.
Yep.
If you want it to be accessible from both Z2 and Z3, then you would add another item to the list, other object to the list for the same region. And if it should be accessible from either Z2 or Z3, I believe, I'm not
That's
sure
what you said,
how
right? This is,
yeah.
Isn't this example like region 1, zone 2, and region 1, zone 3 is an or between these two options, right? Between these two objects.
This is an and in this case.
Why?
I mean, I'm talking about how CSI has defined it. Here, it says this is an and. I mean, based on the documentation right here. It says similarly for volume.
It's saying if a volume should be accessible from two zones. Oh, you're saying it should be accessible from both of them
no,
together?
I'm saying it should. Yeah,
rather
in this
than
case,
just
that's what
in
it's
one
saying.
of them. Okay.
It's together in this case. The idea here is to support volumes that replicate synchronously across two zones. So they're accessible from both zones. So effectively, this is a way to say I want something that is replicated and available from both at the same time.
Mm-hmm. In this case, it's both. So Saad or someone else who's familiar with CSI, is there a way to represent either?
You should be able to. I think you can use, let me see, I'd have to go look at the spec, but yeah, it should be possible. I think effectively it becomes a constrained set of possibilities. You provide a constrained set of possibilities for it to use instead of all available options.
Okay, so.
And this information goes to the provisioner.
Yeah, this information. Yeah.
On the API for create, right?
Yes.
And then the provisioner is responsible for making that happen, but doesn't then need to specify a specific topology for the bucket when it replies?
Yeah.
Yeah, it's like a three-way operation. The first operation is when the node is discovered. The driver says, okay, for this node, these are the labels that apply to it. And the labels that apply to it can be whatever makes sense for that driver. It could be zone, region, rack, whatever.
Mm-hmm.
Then the second piece is when the scheduling of the volume happens, the provisioning of the volume, the Kubernetes side can say, okay, I want this volume to be constrained to these zones only, or to this zone only, or to whatever arbitrary combination of it. And the driver must respect that. And then once the driver has provisioned the volume in the response to the create volume call, it says, okay, this is where the volume is actually accessible from. Like this is the final result. You have a volume and it is constrained such that it's only accessible from, you know, such and such zone, or maybe even a specific node.
Mm-hmm.
And Saad, can you, at the time, after you pick a place, can you say where it is accessible from and where it is preferred from on the way back out?
No, on the way back out, it's just, here's where
this
it's
is where it's accessible
from. Right.
Okay.
How does it initially come up with the list of required and preferred?
So on the Kubernetes side, the scheduler makes, so if you do wait for consumer on
mm-hmm.
the PVC side,
mm-hmm.
then the scheduler influences where the volume is going to be provisioned. And so as part of the scheduling decision, it takes that into account and says, okay, let me help decide where the volume should be provisioned.
Mm-hmm.
And it decides what node would be best for the pod/volume combo. And then it passes, it basically annotates the PVC object with the selected node and says, I, the Kubernetes scheduler, have selected this specific zone, or it says this specific node. And then the external provisioner will take that node information, extract the labels from that node that were previously applied by the CSI driver and say, okay, these are the set of constraints that I have available. And so effectively, if it's a zonal volume, it'll say, okay, this node is constrained to zone A only. I'm going to pass in a constraint on my create volume call that says, I need a volume that must only be available from zone A, not any other zones. And that's how it works. So there's effectively
will it ever pass into the preferred?
I don't think so. I think that was a limitation of the way that it's currently implemented, is that we don't do a preferred, because the scheduler only has a way to say, this is what I require, not anything else. But I think preferred is able to be set manually by the end user. I forget exactly.
In the storage class, presumably?
Yeah.
I think so, yeah.
Okay, so
it's
it's
not by the scheduler.
Really, it's primarily a feature thing, or
yeah, it's future proofing, and I think there was some like ability for the user to set to say, oh, you know, I want the I think it was around like the way that we did stateful sets where, you know, there's a preference for a shard to land somewhere, but not necessarily a requirement, that kind of thing.
How do we say either or here in the requisite topologies?
Yeah, I was looking into that. Let me read through this again. I wrote this, but it was so long ago, I forgot.
Yeah, I think it happens with any code that we write or any doc. Anyways, yeah, while we wait for the response there, so Guy, does this kind of make sense? The explanation for topology.
Yeah, the one thing I imagine there will be the same process where cozy identifies the node properties somehow, right?
So
yeah. We can, but and then so maybe the analogy for CSI is that the administrator tags all nodes in that sense of CSI, so that all nodes have properties related to the CSI plugins that the admin installs. Is that how it works?
Yeah, there is a standard mechanism that CSI uses for that, and we'll be relying on that to get the set of labels for that node.
Okay, and so for cozy, will we have some standard tags for region and zone, like, or is it going to be just nothing? And like each provisioner will have to. So I'm kind of wondering how that works when I'm setting up the a cozy provisioner, right? Will I then have to tag on nodes or provide some rules? How's that working?
Yeah, so each provisioner will have to understand a particular set of constraints. So again, a bare metal provisioner could define them as a rack and either like a power distribution unit or DC center.
But if I have two provisioners, yeah.
I don't think they're intended to be provided by the provisioner. They're intended to be provided by the deployer of the
Agreed,
cloud.
but the provisioner needs to understand what the deployment looks like.
Right. But like the actual strings come from the deployer, and then if the provisioner can understand them, that's good. But the provisioner doesn't get to pick them.
But if not, what does it do?
Works for CSI then, so that I'm deploying the cluster, I'm tagging my nodes being, let's say, racks, for example, for some reason. So I have rack and I have like A to Z or something, and then and then my provisioners have to look up the string rack inside because they assume that this is how I've tagged my nodes.
I guess there would be some cozy implementations that would only be compatible with certain keys
deployments.
But then other ones might be more flexible, and that's up to
look up more keys.
That's up to the, I guess, the designer of the cozy plugin.
Yeah.
Does CSI specify any enumeration of these keys in any way?
No, that was part of the key with CSI. Is it's totally unspecified, and then it's just understood that like if you have I think the GCEPD one, which only runs in Google, only has to understand the Google ones because no one else runs that one, right?
So there's some relationship in the deployment of the cluster versus the cozy deployment. The provisioner and deployment as well in some way. Maybe it's configurable or anything like that, but
yeah, could be. That's true. Yeah. So yeah, those are the three pieces.
So real quick, the Andor question. So effectively, when you provision a volume, in your parameters, you effectively specify whether it is going to be a single zone or multi-zone or whatever. And so that property of the volume is kind of defined on create volume. And so based on that property, the driver knows whether, this is single zone, multi-zone. And so it knows how many zones it needs to select, one zone or two zones. And so from that, if you pass in a list of, two zones, and it needs two, it's going to use both of them. So it says it must be accessible from both. If you pass in a list with 4 zones, but it only needs 2, it is able to select any 2 from that list of 4. If that makes sense.
Yeah, it makes sense. I think in our case, since we're designing it from scratch, I would rather have all of the constraints in one place rather than have this outside mechanism. It's easy to get it wrong.
So the list means either or?
It can mean either or. Effectively it means or, but
when you need to pick 2, you pick 2
no,
out
it's
of the
and.
options.
No, this means and, right?
No, it means or, but
it means
he's
or,
adding another config.
Exactly. So it basically means or. So the list of requisite topology is these are all the zones that, or all the, topology segments that it should be accessible, could be accessible from, pick one. But if your volume requires more than one, for example, it's replicated across 2 or replicated across 3, and the caller has only specified 2 or 3, then all of them are going to get used. So it becomes, this is the constraint set that you must pick from. Pick as many as you need.
How does the user specify that this volume should be in, like, say, 4 zones or 5 zones?
So that becomes a parameter on the storage class. And so, for example,
is that a predefined key?
It's not a predefined key. It's dependent on the storage system. So a given storage system can say that, this is a replicated volume across 2 zones. And so it's, effectively an option for that given storage system. And so for that volume, the CSI driver knows that it needs to select, 2,
4 or 5 zones. Yeah. Now when it responds with a segment. You're saying this segment, if the segment does not include all the 5 zones, then Kubernetes will not put it in the all the 5 zones. It'll just put it in one. Now, given that segment is just a map of string, we wouldn't be able to specify all the 5 zones here.
That's correct, but I believe if you look at the volume object that's returned, message volume, it is a repeated list of topology. So you can return more than one topology to say, okay, it's part of zone 1 and zone 2 and zone 3.
I see. Okay, that makes sense.
I have a question.
Yes.
This relates to figuring out where a bucket can be provisioned based on the node where the workload will run. What if one wants to select where a bucket is provisioned, assuming a globally accessible storage system, no constraints as to which node has access to the storage system?
Right. And so
do you then use a different storage class for every single region, or
just don't set any constraints?
Well, but you may want it to be in a different region. Like I want to create a bucket in AWS US West 1, even though my workload is running in, I don't know, somewhere in Europe.
Yeah, I mean, the provisioner has the freedom to, okay, I see what you're saying. So let me think about this. So you want the bucket to only be provisioned in a particular topology, but you want it to be accessible from everywhere.
Well, let's even assume it's accessible from everywhere to simplify.
Yeah.
Say I'm building a system where the workload runs in Europe, and I always want to store my objects twice, once in the US and once in Europe or whatever. Then I will have a bucket request, or I will have 2 bucket requests as part of the workload deployment. In one, I'll say I want it to be in US. In the other, I'll say I want it to be in Europe. How do we pass that through?
Isn't it just somehow separate set of topology keys? So region might be applicable to like the bucket location, whereas a site or something might be related to the node's location. And then I'm not sure what's coming back then from the create bucket then. But I can say, well, I want to restrict region, but I don't want to restrict the site in any way.
So maybe, maybe when AWS, the constraints that are set are only on where the bucket should be provisioned. In case of AWS, for instance, or in case of providers where buckets are accessible from every region, let's say, I think we can set this kind of requirement that the provisioner should return all the different regions from where the bucket is accessible, without trying to restrict by preference and other things.
Well, this actually feels like a case where the preferred topology makes sense. So you could say that the allowed topology is everywhere, but the preferred one is where you want it.
No, but we're assuming that we want to schedule based on bucket availability. I think we would...
Right, but we're also presuming for this example that buckets are going to be available everywhere. So limiting by availability
not
doesn't...
everywhere. Everywhere that this segment responds with. So if the buckets are available in just 4 regions, and that's the extent to which it can possibly be available, then you would respond with 4 regions in the segments. And it's up to the workload to choose to run in either region 1 or region 2. And we can leave it that way.
And how does that change over time? Let's say that today there's 3 regions and everything is accessible from everywhere. So the provisioner returns region 1, region 2, region 3. And then a couple of months from now, there's a new region.
Oh, well, if it's literally accessible from all the regions, you can just return an empty list, and that implies everywhere.
Okay.
So for the wildcard case, you can just use the empty list.
Mm-hmm.
But an enumerated list of regions implies exactly those regions.
Yeah.
And so what does the mapping between, so when we talked about it on Monday, like the follow the pod versus follow the volume or the bucket, right? Modes. And so when we tag these constraints like region, what does it mean for nodes? Because nodes not necessarily, map into regions. Like we say in this global case, all nodes can access all regions, right?
Yeah, I think that's why we were talking about getting the topology keys from when the driver starts on the node. So we have that mapping of which node belongs to which region and whatever other constraints.
But they may not be related. If my
right,
Kubernetes cluster is on premises and I'm using AWS S3, then
I'm using all regions. So to which region should I assign my nodes in this case?
If it's accessible everywhere, it doesn't matter.
Yeah.
So, okay, so what will be the assignment that is done? That it's an empty list. The node is assigned to an empty list of regions, and that means all regions. Is that?
So the important thing we talked about on Monday is that the pod scheduler does not attempt to put pods close to volumes or close to buckets, right? The pod scheduler just does what the pod scheduler does. If you wanted to go to a place, it's incumbent upon the user to put a topology on their pod or select the specific node when they specify their pod. The scheduler will not look at your PVCs or your buckets and try to get the pod close to them. Is that correct, Saad?
Sorry, I wasn't paying attention.
The pod scheduler does not pay attention to PVs or PVCs or in the future buckets when it decides how to schedule the pod, right?
If the unless the PVC is wait for consumer.
Well, no, but even in that case,
Uh-huh.
the pod just gets scheduled where it's going to get scheduled, and then the PVC tries to get close to that pod. But
Effectively, yes.
but if you already have a PVC that is in a place and you create a pod that attaches to it,
right,
the scheduler will not try to get the pod close to that PVC.
It will. So you could create a volume basically independent of kind of the scheduler, and it gets scheduled wherever or provisioned wherever it does. And then the CSI driver will apply topology constraints on the PV object saying, hey, this is only accessible from, for example, zone A.
Okay.
And then when the scheduler has a pod using that volume, it says, oh, okay, I know that the volume being used by this pod is only accessible from zone A. Therefore, I will restrict this pod to zone A so that the volume can actually run.
That's
okay,
follow the volume mode as well.
Yes.
Mm-hmm.
So I didn't know we had that. So
yeah.
So can we do the same for buckets?
How would that look?
I would still look at so with PVs, which are used like this, I'm not sure if the problem arises that we have different kind of maybe you answered it, but I'm not sure. So different kind of region zones. But when you have like an NFS kind of any network storage or NFS or any kind of network storage where you have like the target storage has its own kind of failure domains or whatever,
yeah.
but the cluster has a different set.
Yeah,
Is there
that's a good kind of question, and we have exactly this. So on the volume side, what we said were these are two separate problems. There's a reason we call this accessibility topology. And the reason is because it's effectively the accessibility of that volume, whether it is actually accessible by a node or not. The second kind of thing is storage topology, which we have not tackled on CSI yet, which is what you're talking about, the idea that the volume is equally accessible from all nodes, but it has some sort of internal topology where it makes sense to influence where it lands, maybe an internal failure domain, that kind of thing. We're looking at that now as part of Kubernetes designs, but it's still very much in the design process.
I actually like that. I think that puts a clear line between the two things we're talking about.
Yep.
But it also means that we will not have, for the starters, a region kind of functionality.
No, we don't have to rely on CSI.
Oh, I mean, you're saying we need to solve it as well, right? To have storage versus. Okay, I got it. Oh, so I thought you said to not have it. Okay.
Yeah, for CSI, it was just the more immediate problem was accessibility topology, and that was tackled. The failure domain internal storage topology problem exists, but it's mostly a nice to have. It's like a micro optimization kind of thing. So that's why we deprioritized it, but we're starting to look at that now as well.
Right, got it. So how about that? How about we have the two concepts, accessible topology and storage topology. Storage topology would be sent on the request. I'm thinking this through as we go along. So I'm thinking maybe storage topology could be sent as a request parameter to create bucket. And on the response, we get accessible topology.
The really tricky thing about storage topology is that it could be completely independent of the kind of cluster's own topology. And so effectively what we need is some mechanism for the storage system to be able to say, hey, Kubernetes, here is my internal topology layout. Have Kubernetes store that information and then be able to operate on it in the future. And so when you start getting into
bucket classes, no?
Potentially. But when you start getting into this territory, it comes down to a question of, does it even make sense for Kubernetes to be making these decisions and start, effectively influencing something within the storage system. Where does the line draw? And
No,
that's why I lost it.
The Kubernetes is not modeling the object storage system itself. The topologies will be a set of keys that will be provided by or understood by a particular provisioner. As far as Kubernetes is concerned, it's completely out of band. How it makes that happen? So stuff like saying I want a bucket in region US East 1. All that Kubernetes will model in our case is accessible topology, which is for the pods to get scheduled correctly.
Right. So you're saying the failure domain storage topology would be handled on the kind of storage system side.
Mm-hmm.
Okay.
Yeah. Let me do this. So I don't know how much time is left. Yeah, we're almost done. So I'll try to put this together with the two concepts of storage topology and accessible topology, and I'll also try to see how I can do the weight on consumer kind of behavior, follow the volume versus follow the pod, and let's continue this discussion on Monday.
And so for storage topology, we actually discussed about that a little bit when we were working on the storage pool cap, which is now the storage capacity. I think at least for that revision, we decide not to pursue it. But the volume group cap that I'm working on, actually also trying to look at how to do spreading and then see if that can be applied for this storage topology related concept. But yeah, we haven't figured out yet.
I see.
Yeah.
I see. Okay, good to know. Yeah, let's reconvene on Monday, and we'll go from there. Shing, we'll update the pull requests, and I think Shing has already updated. We'll send the email, and yeah, we'll follow up on that. That's it from me.
Awesome.
Thank you. Bye.
Thank you, everyone.
Thanks.